This video is on the many relationships organisms have in an ecosystem. One way to show the relationship between organisms is in a food chain. A food chain shows the steps of energy flow in an ecosystem. Look at the picture on the right. The flower is eaten by the grasshopper, which is eaten by the mouse, which is eaten by the snake, which is eaten by the hawk. Notice the order of the organisms are in. The producer is always the first organism in a food chain because they are the first organism to be eaten. They get their energy directly from the sun. They change the sun's energy into glucose through a process of photosynthesis. Producers are always first. Food chains actually are not that accurate because it only shows one path. Food webs, though, show many food chains, and they are much more accurate because it shows many different feeding relationships. This is an example of a food web on the right. There are many chains in this food web, but it shows that organisms have different possibilities of food sources. They eat multiple organisms. When you look at a food web or a food chain, what do you notice about the direction of arrows? Which direction do the arrows point? Notice producer, arrow, primary consumer, arrow, secondary consumer, arrow, tertiary consumer, arrow, quaternary consumer. The arrows always point in the direction of energy flow, meaning the energy in the molecules of that organism are being passed from one organism to the next, to the next, to the next. By the way, this is probably the most common mistake people make on tests or on the MCAS. They put the arrows in the opposite direction. Don't do that. Arrows always start at the producers and then go to the consumer and the next consumer and the next consumer. Don't draw your arrows backwards. Look at this food web. Notice the food web starts with the producers, then there are some arrows to the primary consumers, then arrows to the secondary consumers, and on and on and on. This is always the order of organisms in a food web or food chain. You always start with producers. They are level 1. Because they get the energy first. They get all of their energy from the sun, and through the process of photosynthesis, they convert it into glucose or sugar in their bodies. Then a primary consumer eats a producer. The primary consumer is the second level of every food chain or food web. Then a secondary consumer is the third level because it eats the primary consumer. Then you draw an arrow and you have a tertiary consumer, which is the fourth level because it eats the secondary consumer. This is always the order, and this is always the numbering. Producers are 1, primary consumers are 2, secondary consumers are 3, tertiary consumers are 4. Let's apply the same thing to a food web. Notice the producers are first, then the primary consumers, secondary consumers, and tertiary consumers. There's one very important thing I want you to see from this picture, that every single organism is dependent on the producers. What would happen if there were no producers? Well, then there'd be no food for the primary consumers and they would die. And then there'd be no food for the secondary consumers and they would die. And then there'd be no food for the tertiary consumers and they would die. Every single organism is dependent on the producers. If the producers decrease in their population size, there go the rest of the organisms. If they increase in their population size, then maybe there are more primary consumers and therefore more secondary consumers and more tertiary consumers. The producers are very important in a food web. There is one final type of organism that is sometimes shown in a food web. They are decomposers, organisms that eat dead animals and plants and break them down and return their nutrients to the soil. Common examples of decomposers are bacteria and fungi. It's hard to connect decomposers to the rest of the food web because since they eat all the dead bodies of all the organisms, you'd have to have an arrow going from each organism to each decomposer. So for instance, an arrow from the rabbit down, arrow from the grasshopper down, woodpecker down, and that gets really messy. So a lot of times they don't even put arrows for decomposers. You're just supposed to know that decomposers eat the dead bodies of all of these organisms. So what would happen if the producers in this ecosystem decrease? What would happen to the grasshoppers? They'd also decrease. Cottontail rabbits, they would decrease. Field mouse, decrease. Carpenter ant, decrease. Well, what about the woodpecker and the shrew and the snake and the fox? Well, since their food source decreased, they would also decrease. So if producers decrease, so does everything else. What would happen if the foxes in this food web would increase? Well, if you had more foxes, they would eat more food. So the shrew would decrease, the field mouse would decrease. And if these guys decrease, what do you think is going to happen to the rest? Well, if they decrease, maybe the grasshoppers might increase because there's less mice and less shrew to eat them. It gets kind of hard down here because we don't know all the relationships, but if a predator increases, usually their prey decreases. What happens if the rabbits emigrate, meaning the rabbits leave this population? Well, if you have less rabbits, you might then have more grass because it's eating less grass. If you have less rabbits, maybe you would have less foxes because they would have less food to eat. Who knows? There's many relationships, but you should understand the basic connection of all of these organisms. Now that you understand food webs, we can discuss how energy travels through the food web. Every level in a food web or chain is called a trophic level. So we have producers, primary consumers, secondary consumers, tertiary consumers are all called trophic levels, the steps in a food web. Remember, the most important trophic level is the producers because everything depends on them. All the energy originally starts with the producers because they get their energy directly from the sun, and through the process of photosynthesis, they convert that sun's energy into glucose or sugar. When the primary consumers eat the producers, only 10% of their energy gets passed on. When the secondary consumers eat the primary consumers, only 10% of their energy gets passed on. This is called the 10% rule. Only 10% of the energy is passed from one trophic level to the next. Well, why? What happened to that other 90%? Well, 90% of the energy that originally started with the organisms is used for the daily activities like growing, running, jumping, cellular respiration. It's oftentimes released as heat. This is why only 10% of the energy gets passed on to the next organism because 90% is used. Again, this is called the 10% rule. Only 10% of the energy is actually stored in the body. The remaining 90% is used for daily growth. Scientists like to show this amount of energy available to each level by putting the trophic levels in a pyramid. Because the producers have the most energy, it goes at the bottom of the pyramid where there's the biggest size. Then they put each subsequent trophic level on the pyramid. So remember, the producers in this example would be grass, and then if we follow one food chain up, the grass is eaten by the grasshopper is eaten by the mouse, and the fox eats the mouse. So this would be my energy pyramid. The grass would have the most energy, grasshopper would have the next, mouse the next, and fox the next. So remember, the producers are trophic level 1, it goes at the bottom. Primary consumers are second, secondary consumers are third, tertiary consumers are fourth. If producers start with 100% of energy, only 10% gets passed on to the primary consumers. Therefore, they have 10%. So then, if a secondary consumer eats a primary consumer, only 10% of the 10% gets passed on. Only 1%. If only 10% of the 1% gets passed on, then the tertiary consumers have the least amount of energy, which is 0.1%. So remember, producers have the most energy and subsequently have the most number of organisms. There are more producers than anything else in the world. Tertiary consumers, or even anything after, would have the least amount of energy and therefore have the least organisms in an ecosystem. Think of the number of bears, lions, foxes, anything that would be a tertiary consumer. There's not that many of them compared to all the other trophic levels. Would more energy be available to the mouse if it ate a grasshopper or the grass? Look at the mouse. The mouse can either eat a grasshopper or the grass. Which would provide the mouse with more energy? Well, if the mouse ate the grasshopper and the grasshopper ate the grass, that would mean the mouse would only get 1% of the energy because the 10% rule. Only 10% goes to the grasshopper, 10% of 10% goes to the mouse, which is 1%. But if the mouse ate directly the grass, then the mouse would have 10%. So the answer to this question, the mouse would have more energy available if it ate the grass instead of the grasshopper. Even though I didn't directly say these words, you now know about the predator-prey relationships in ecosystems. Predators are animals that eat other animals. For instance, the red fox, the garter snake, the shrew, the mouse, the woodpecker. They are all predators. They are eating other animals. Prey are animals that are killed for food by predators. For instance, the carpenter ant is killed by the woodpecker. The grasshopper is killed by the mouse. The mouse is killed by the snake. The cottontail rabbit is killed by the fox. Those are all examples of prey. Here's an example. If the fox population increases, what would happen to the shrew population? So here's our fox, the predator. Here's the shrew, the prey. If you increase the amount of foxes in a population, it would decrease the amount of prey because the foxes eat the prey. The foxes eat the shrew. This graph is showing you how the predator and prey populations change in relation to each other. For example, when the hare population, which are the prey, increases, so does the population of lynx, which are the predators. So in this case, we have hare is purple. There's the purple increasing. And lynx, which is the predator, is blue. So when the hare increases, so does the lynx population. When the hare increases, so does the lynx population. Because the prey is the predator's food source, more food means a higher birth rate for the population of predators. So the population increases. But when the predator population gets really, really high, they start killing off many of the prey, and so the prey's population decreases. The death rate of the prey population will increase, causing their population to decrease. I feel like I just rambled on, but does that make any sense? When the predator numbers are really high, like right here, the prey population decreases because all the predators are eating the prey. So the prey's death rate is high because they're all dying. Another type of relationship is competition. For example, the shrew and the field mouse compete for the same food source. They both eat grasshoppers. Therefore, the shrew and the field mouse are in competition with each other. What's another example of competition? Well, the fox and the garter snake are both competing for the field mouse. Therefore, the fox and the garter snake are competitors. They are in competition with each other. Or the field mouse and the cottontail rabbit are both competing for the grass. They are in competition with each other. Therefore, they're competing for the same food source. If the field mouse population increases, what will happen to the shrews? All right, so look at the picture. If the field mouse increases, you're going to have less grasshoppers, right? Because field mouse is the predator, grasshopper is the prey. If you have more field mice, you'd have less grasshoppers. So the question is, what happens to the shrew then? Well, if you have less grasshoppers, then the shrew's not going to get enough food. Therefore, the population of shrew would decrease. So to answer the question, when the field mice increase, the shrew population decrease. Organisms can live and work together, and when two organisms work together and both of them are benefited, this is called mutualism. For example, in the picture in the top right, the flower provides food for the bee, and the bee transports the flower's pollen to other plants for fertilization. Or in the picture below, the termites have little organisms in their stomach called protozoa. These protozoa break down the wood that the termites are eating, and the termites give the protozoa a home to live in. Both of these organisms are benefited by living and working together, so they are in a mutualistic relationship. If two organisms live and work together and one of the organisms is benefited and the other is not affected, this is called commensalism. For example, the birds are resting on the horse, and the horse is not helped nor harmed by the birds. The clownfish lives in the sea anemone and uses it for protection from the other fish. But the sea anemone is not helped nor harmed. It just doesn't care. Therefore, this is an example of commensalism. Finally, parasitism is a relationship in which one organism is benefited and the other is harmed. The picture in the top right is showing a tapeworm. You could accidentally eat a tapeworm egg without even knowing it, and it would grow into a worm inside your intestines and would eventually kill you. Tapeworms can get up to 6 feet long, and they would take all the food that you are eating, and eventually you would die from starvation because it's getting your food. They are helped, you are harmed, you die. That's parasitism. The picture in the bottom right is showing a fungus that has infected an ant. In the end, the fungus killed the ant. This is parasitism. That's all I have. Write down your questions and ask me in class.